Hello everyone, more used up today. Let's look at this integral. We have this x cubed times the square root of x squared plus 7. And this is not the usual u sub problem where we just let u be the inside of the square root and then whatever du that we're getting will cancel out with the rest of the stuff and then that will be all nice, right? But that's not going to be the case here because we're having an x cube in front of the square root. But we still got to do it anyway. And then hopefully good things will happen, right? But we will just try it and see what's going on. So we are going to start the problem by letting u be the inside of the square root. So we are going to get x squared plus the 7. And then what about the du? The du is going to be the derivative of the x squared plus 7. So we get 2 times x and then times the dx. Now, as you can see here, there is not anything that we can cancel the 2x right here. So let's try to solve for dx and see what can be canceled. So let's divide both sides by the dx. So we're going to get 1 over 2x. I mean, divide both sides by the 2x, not dx. Okay, so if we divide both sides by the 2x, then we are going to get 1 over 2x du. And that's equal to the dx. And then now, because we isolated dx, then we can actually replace this dx by this expression right here. So instead of doing our usual matching manipulation, then we actually will just solve for dx and then make that substitution in here to see if there is anything that can be canceled. Okay, so now we are going to go back to our original integral and see what's going on. We have the integral, and then there was the x cubed here that we didn't touch, and then there was the square root, and then what do we have here? We make that substitution. We call u x squared plus 7. So now I'm going to replace the x squared plus 7 with u. And then there was also the dx that we need to replace, which is this expression right here, 1 over 2x times the du. So we are going to get 1 over 2x and then times the du. And then as you can see here, we are going to cancel the this x in the denominator with this x cubed in the numerator. And of course, they don't get completely canceled. We still are going to get an x squared right here. So, but let's just cancel them anyway, right? So we are going to cancel the 3, so it becomes a 1. Okay, so now we are going to simplify this integral here before we continue to do more work. So I think I need more space. So right now, let's continue with this integral. We are going to get the integral of x squared and then the square root of u and then times the 1 over 2 and then the du. And then of course the 1/2 can be brought outside the integral. So we get 1 over 2 and then the integral of x squared and then the square root of u and then du. Now, here comes the problem. To integrate this function, we need to have everything in terms of u. We cannot have the original variable x in the integral here. So right now we cannot integrate yet. Then you may say, isn't that a problem here? Because our u sub does not let us cancel out the x squared. But we can actually do some extra work in the u sub so that we can get rid of the x squared. How do we do that? You see that we can go back to the original u sub problem here. And what we can do is that we can actually turn this equation into an equation with the x squared isolated. So what are we doing? We can subtract 7 from both sides of the equation. So it becomes u minus 7 equals x squared. Okay, so now because x squared is equal to u minus 7, then we can actually replace this x squared by u minus 7, and then we have a function that's just in terms of u without the x. Okay, so let's do that. So it becomes 1 over 2 integral of now u minus 7. So I'm going to replace that by u minus 7 here, u minus 7. And then there was the square root of u. And then there's this du. Okay, so now it's possible to integrate this function. Everything is in terms of u, and then of course there was a product we can distribute, and after distributing, we can integrate term by term. And so let's do that. So we have 1 over 2, and then the integral of now the u times the square root of u, which is u times square root of u. I'm just showing more work here, and then minus. And then what about this? This is 7 times square root of u. So we are just going to get 7 times the square root of u. Okay, so that's nice. What do we need to do next? The next step is that we can rewrite this u in the power form, then combine with this u so that now we have a u in the power form. So we can just make a note right here. This is actually just what? This is actually u to the 1 over 2, right? Yeah, so the same thing for that one. So our next step is to just put this u and multiply with a u to the 1/2. Then we are going to get a new looking integral, which is 1 over 2 integral of u to the 3 over 2. Why is it 3 over 2? Because we are taking u to the first times u to the 1/2. 1 plus 1/2 will give you the 3 over 2. And then minus 7 times u to the 1/2. Okay, almost done, right? Those two terms can be integrated directly. So let's do that with the integration. We have 1 over 2 integral of, actually we don't need the integral anymore. We are integrating. So we're just going to get 1 over 2, and then let's put a pair of brackets right here. And then we are going to get we are going to add 1 to this 3 over 2. So adding 1 to it will give us 5 over 2. And then to reverse the power rule, we actually need to multiply by the reciprocal of our new power, right? So the new power would be 2 over, the new coefficient. The coefficient will be 2 over 5. And then minus, there's a 7 there, and then we are going to get the u to the, we are going to add 1 to the 1/2, which will give us 3 over 2. And then we need to multiply by its reciprocal, so we are going to get 2 over 3. And so distributing the 1/2 at the same time, then we actually will be getting 1 over 5. Oh, I'm forgetting the plus c right here, but I will just put it at the end. So we are going to get 1 over 5, and then u to the 5 over 2. And then minus, what is that? If we multiply by the 1 over 2, then we are going to get 7 over 3. Why is it 7 over 3? It's really because the 2 and this 2 will cancel, and then you just have 3 times 1, 7 times 1/3. So we're going to get 7 over 3. And then the u is just that u to the 3 over 2. Okay, lastly is really just to switch the u back to the original variable. So we are going to get u is turned into x squared plus 7. And then 5 over 2 minus 7 over 3. And then again, it's going to be x squared plus 7. 3 over 2, and then we plus the constant c. And then we are finished with this problem. Yes. What is the difference if you compare this problem with the most basic one? Is that the most basic one is that you have a x on the outside. It may contain a coefficient, but then it's usually just the x. So when you let u be x squared plus 7, and then the du will actually give you the x that will cancel with this x here. But for this problem, that's not the case. We are required to do this extra step right here, the screen step right here, so that we can do another substitution to turn the rest of the expressions involving x into expressions involving u. Okay, so that's the problem, and we are going to do other integration types next time. Thank you for watching, and if you like this video, please subscribe to my channel and give me some support. See you next time.